Hi, Megan. Thank you for your question. So I have it up. I'm going to do A on as an example, and then that will leave you B and C. So first of all, what we're given is that we're given the formula for hematite, which is Fe2O3, so 2 irons for every 3 atoms of oxygen. And we're going to calculate the mass in kilograms of each of this compound if you're given 1 times 10 to the 3 kilograms of iron. So you're given the iron piece but not the oxygen piece. Can we say what the final mass of the hematite is going to be? So first of all, just a couple of things. We are going to, if we're looking at a solutions map, we're going to need to convert kilograms to grams because our molar mass on the periodic table is always shown as grams. In the end, we'll convert the grams back to kilograms as the question asks us to do that mass in kilograms, to give the final mass in kilograms. We need to know what the molar mass of hematite is, so we're going to figure that out. And then we're going to find the mass percentage composition of Fe in the hematite. And then once we get the mass composition, we will then find the total mass of Fe2O3. And then lastly, we're going to convert the grams back to kilograms. So that's basically what we're going to be working through in order to solve question A for this. So first of all, we need to take 1.0 times 10 to the power of 3 kilograms, and we need to convert it to grams. So 1.0 times 10 to the 3 is 1,000 kilograms. And 1,000 kilograms to grams, we multiply by 1,000, so that's going to give us another 3 zeros. So 1,000 kilograms equals 1 million grams. So there's our first task done. Now we need to find the molar mass of our hematite. And that's going to be 2 times the molar mass of iron, because there are 2 irons, and the molar mass of iron from our periodic table is 55.85 grams. Added to that are our 3 oxygens at 16 grams per oxygen. So in total, that's going to be 159.7 grams is our molar mass of Fe2O3. So that's our molar mass. The next thing we're going to do is use that molar mass to find the mass percent composition of iron within hematite. So to do that, we're going to find the mass percent of Fe in the hematite, and that's going to be twice the molar mass of 55.85, so twice the molar mass of iron, divided by the total molar mass of the hematite. This will give us our mass percent of iron, which is going to be, and then multiplied by 100, of course, to get it as a percent. And that gives us 69.9% of hematite is iron. This is a key number here because that's what's going to help us find the total mass of Fe2O3. So now we're on to this step 4. How do we find the total mass? Now that we know the mass percent of iron in the hematite, how can we use that to find the total mass of the hematite put together? Sometimes I like to write things into English and then convert them to math. So basically what we have is that we know that 69.9% of hematite is going to equal the mass of our iron. Once I write it in English, I'm then going to convert or translate that to math. 69.9 is going to be a decimal when we translate to the math. Of always means multiply. The mass of the hematite is what we're looking for. So we don't know that. And that's going to equal the mass of our iron, which we know to be oh, did I do that wrong? Nope, that's right. Which we know to be 1,000 grams. Sorry, 1 million grams. There. So we know that we have 1 million grams of Fe. We know that 69% of hematite is iron. We're just looking for the hematite. So that's our unknown. So I'm going to use algebra to figure this out. Let's say that our unknown, instead of a question mark, is going to be our unknown x. So we're multiplying by x, so I can just leave that as is. So 0.699 times x is equal to 1 million grams. And then using algebra, I'm going to divide both sides by 0.699. That's going to leave me with the mass of hematite, and 1 million grams divided by 0.699 gives me 1430615.2 grams. And then the last part of this is to convert it to kilograms. So I'm just going to move my decimal over 3 places, which is the same as dividing by 1,000, and I get 1,430.6 kilograms of hematite is my answer. And that's the last part here, is this conversion from grams to kilograms. So again, I'll have 1,430.6 kilograms as my answer to this question. So I hope that helps in solving your question. Let me know how it works out for you. I hope this helps you in solving B and C, because you're going to do the same, go through the same solutions map as we did here. Thanks for watching. Bye for now.